Good morning, my dear students. In today's class, we are going to start the chapter Matrix. So these are the points which we want to discuss today. First, a written topic, that is matrix, to be discussed today. We will discuss its definition first of all, then order of a matrix, then type of matrices. These are the types which we have to discuss. They are very important. Row matrix, column matrix, zero or null matrix, square matrix, diagonal matrix, scalar matrix, identity matrix. These are written in a specific order that I will discuss one by one. And after that we will discuss formation of matrices, and in the last equal matrices, means how the two matrices are equal. So let us know all these one by one. It's a very starting class, so we will understand all the things from the beginning only. So first let us know what is the definition of a matrix. Children, a matrix is an arrangement. Let us be very clear. It is not a single number. It is most often group of numbers. It is group of numbers. It is not a single number. It is group of numbers, and we arrange that group in a specific manner that is called rectangular arrangement. So we can write a matrix is a rectangular arrangement of numbers or values, whatever you can say, numbers or values. A matrix is a rectangular arrangement of numbers or values. They are usually represented by any of the letter of English alphabet, but capital letter. Matrices are always represented by the symbol, any alphabet of any capital letter of English alphabet, from A to Z, any one you can use. Suppose we can show it by an example. Matrix A has its values 2, 3, 4, 5, 6, 7. See the example. These are the marks obtained in physics, chemistry and maths by two students, suppose Ram and Shyam. So I said this is the rectangular arrangement of numbers. We want to show the numbers, the marks obtained by two students out of 10 marks test they had given. The Ram is a child and the Shyam is another child. They are getting marks in physics 2 marks out of 10. Shyam is getting 5 marks out of 10. At the same time in chemistry, Ram is getting 3, Shyam is getting 6. In mathematics, Ram is getting 4 and Shyam is getting 7 marks. So the whole arrangement have been shown as a matrix. I think this will clarify how the matrix is a rectangular arrangement. So let us be very clear once again. It is not a single number. It is a collection of numbers. It is a group of numbers. It is an arrangement of numbers. In rectangle form, because we can see that it is in rectangle shape. Children, the horizontal informations are called rows. Be very clear. The horizontal means this type of lines are called horizontal lines. Horizon word express horizontal, and these are called vertical lines. Clear, friends? These are verticals, these are horizontal lines. So horizontal informations are called rows. Row 1 you can say this one, and the other horizontal information is row 2. So this information or this matrix has how many rows? 2 rows. First row and second row. At the same time, the vertical informations, this one as well as this one as well as this one also, are called columns C1, C2 and C3. So once again, vertical informations are columns, whereas horizontal informations are the rows. Means Ram marks are the rows in row 1, Shyam marks are in row 2, whereas physics marks are in column 1, chemistry marks are in column 2, and the maths marks are in the column 3. Is this clear, students? Be very clear about the rows and columns. Once again, rows are the horizontal informations, whereas vertical informations are columns. By this way, we represent any matrix. After this, let us know the order of a matrix. After definition, we are going to understand order of a matrix. Children, let a matrix A has m rows, it contains m rows and n columns, then its order is given by m by n. We write m into n, but it is customary to read m by n. क्या पढ़ेंगे? M by n. The order of the matrix is m by n. Symbolically, you can write order of A is m by n. So, in the example we had just before, what was the order, children? There were 2 rows, याद है ना? There were 2 rows and 3 columns. So, in our previous example, 2 by 3 was the order of that matrix. So, is it clear? In first place, number of rows are to be written, and in the second place, number of columns are to be written. There is no variation. Always these are the rows, these are the columns, and their product type of representation is called order of the matrix. Clear to all? After this, we are going to understand those types of matrices. The first one was row matrix, children. I am telling you one by one. I will read the definition and will show all by example, suitable example. So first heading is types. Among the types of matrices, we are having the first one as row matrix. Children, a row matrix is that in which only one row is there. Whatever the number of columns it might have, but a row matrix will have just a single row in it. Let's understand this with the suitable example. 2, 3, 4, minus 5, 1. We don't put comma in between the elements. Be very clear. याद करिए, in set theory, suppose it could be a set taught in class 11th. If it would have the elements 3, 4, minus 5, 1, you would put the commas in between. But in matrix, it is not to be used. Commas are not to be used. Be very clear in symbols in maths, because numbers are very important things in math. Symbols are very important in mathematics. So commas are not to be used. Be very clear. So I wanted to tell you row matrix. Row matrix is that in which only single row is there, only one row. But vertical informations are many more. 1, 2, 3, 4. There are 4 columns, we can say. In this example, children, there are 4 vertical informations, whereas 1 horizontal information. Horizontal information is just 1. So it has just a single row but 4 columns. So its order is 1 by 4. Such type of matrices in which there is a single row, whatever the number of columns, as I said in the beginning, is called a row matrix. रो मैट्रिक्स में केवल एक ही रो रहेगी, कॉलम्स कितने भी हो सकते हैं. आफ्टर दिस द सेकेंड इज कॉलम मैट्रिक्स. I think you are very comfortable to explain this also in the same sense. In a column matrix, there will be a single column, whereas whatever the number of rows it might have. So, The example C will help us to understand this column matrix. The same we can write other also. 5 minus 7 4 3 1. This is a good example for column matrix. What is the definition? In column matrix, there is only one column, whereas it might have any of the number of rows. Children, we can see that it has these many rows, whereas a single column, see, whereas it has single column. So number of rows are how many? 1 2 3 4 5 rows and a single column, one column. So 5 by 1 is the order of C, and it is a good example of column matrix. Is this clear? In column matrix, single column. In row matrix, single row. Whatever the columns in this, no problem. Whatever the rows in this are not the problems. By this way, I think we are clear about the row and the column matrices. Now, the third is zero or null matrix. I think one can guess about it by its name only. Its name is zero matrix, children. Zero matrix is that in which all the values or all the elements or all the entries, whatever words you can use, a matrix in which all the entries are zero, all the elements are zero. Zero or null matrix. Children, zero matrix are usually represented by O only. Out of all the English alphabet A to Z, O is only prescribed to represent any null or zero matrix. It is also a matrix of any order, doesn't matter what the order it has, but it's all the entries must be zero. See? Children, what is the order of this matrix? One row, second row, third row, one column, second, third, 3 rows and 3 columns. So it is a 3 by 3 order zero matrix. So what the clarification of zero or null matrix? A null matrix or zero matrix is that in which all the elements are zero. All the entries, all the inside values are zero there. This is the zero matrix. Very easy. The next ones are very, very important, and they are in chain actually. All these are in chain. The first is bigger than the next one. Like, first we are going to discuss square matrix. Very, very important. A square matrix is that matrix in which number of rows and number of columns are equal. A matrix A with order m by n is called a square matrix. A square matrix if m is equals to n, that means number of rows are equal to number of columns. Number of columns, students. If a matrix has same number of rows and columns, it is called a square matrix. In a square matrix, rows and columns are same. That's why the name is given square size, square matrix. Let's have an example to understand square matrix. Just before we had taken a zero matrix, it was also a square matrix. Why? Because the number of rows and columns were same there. But we will take some other example. Matrix D is equal to 3, 4, 5, 7. Yes, it is also a good example of square matrix because it has 2 rows as well as 2 columns. If these numbers, this only we were saying about m by n. If m is equal to n, then the matrix is called a square matrix. Let's have some more examples to understand of other orders also. 2 minus 1 0, 5 4 0, 0 0 4. It is a good example of square matrix. What the order, children? 3 rows and 3 columns. It is a 3 by 3 square matrix. We can have 1 by 1 square matrix also, means a single element. This is also matrix, undoubtedly it is a matrix, and its order is 1 by 1 beta. It has single row and single column, so it will also be a square matrix only. Be very clear. Square matrix is that in which the number of rows and number of columns are same. In our syllabus, in class 12 studies of matrices, children, our main goal will be to go with only 1 by 1 or 2 by 2 or 3 by 3. That was only 4 by 4 type of questions will not be there to solve or to go ahead. We will have the highest order is 3 by 3 only, not more than that. To solve particularly, or means to add or to subtract or to multiply. So we have to focus only up to 3 by 3 matrices. After this, square matrix will help us to know the next one, that was diagonal matrix. The diagonal matrix is a square matrix. Let me put heading. Diagonal matrix. A diagonal matrix is that it is a square matrix in which all non-diagonal elements are zero. Try to understand. It is a square matrix in which all non-diagonal elements are zero. That means, let's have an example to understand. Matrix G is equal to 2 0 0 0 5 0 and 0 0 minus 11. Children, the diagonal word is used for this diagonal actually. The diagonal word has been used for this diagonal, although we say this another diagonal as subordinate diagonal. This one is principal diagonal. But if the diagonal word only is used, please go through the principal diagonal. Please understand that it is the principal diagonal only. There is not much concern, not much focus on the subordinate diagonal. Subordinate diagonal को ज़्यादा भाव नहीं दिया गया है. So diagonal word means only for the principal diagonal. So that's why I've written here. So let us go again with the definition and try to understand why this example is. It is a square matrix in which all non-diagonal elements are zero, means except the diagonal elements all other must be zero. See, all others are zero except these. All others must be zero. That only is the definition of. Children, we have some other symbol also, other type in other way. In other type also we can write the diagonal matrix. Diagonal matrix G is equal to, only the diagonal elements are written because one knows that all other entries will be zero there. So we can represent the diagonal matrices by this way also. Sometimes you might have such type of representation of the diagonal matrix. So be very clear. They are to be placed in the diagonal places, and other places you know they will be zero. So you can frame the original form with the help of this symbol also. I think I'm clear about diagonal matrix. Diagonal matrix is a square matrix. First thing, it is undoubtedly a square matrix, and it's a non-diagonal elements will be zero. Only the principal diagonal, which usually known by the name diagonal elements, should only be something whatever. One more question arises: will these elements also be zero? Yes, they can be. These elements can also be zero, either all or some. But the main concern is that all non-diagonal elements must be zero. इन एलिमेंट्स के बारे में कुछ नहीं कहा गया है कि ये जीरो हो कि सारे जीरो हो कि एक भी जीरो ना हो. No matters. The main concern is what? That non-diagonal elements must be zero. Non-diagonal elements must be zero. Diagonal elements में कुछ भी हो, यहाँ चलिए हम जीरो लिख के दिखाते हैं आपको. लीजिए. This is 0. Yes, it is also a diagonal matrix. Undoubtedly, 100%. Don't be confused. It is also diagonal matrix because all the see the definition, be very clear. Only the focus has been done, focus has been given on the non-diagonal elements in the definition. About diagonal elements, nothing has been told. About the diagonal elements, nothing has been told. The next definition is scalar matrix. Scalar matrix is a diagonal matrix, first thing. It means the scalar matrix is the branch of diagonal matrix. It is a special type of diagonal matrix. So we will define scalar matrix with the help of diagonal matrix. Scalar matrix. A scalar matrix is a diagonal matrix in which each diagonal element will be K, means same. What does it mean? The diagonal elements will be identical, any scalar, any constant. See the example to understand definition. Suppose H is a matrix. Undoubtedly it is diagonal because we have defined scalar matrix with the help of diagonal matrix, friends. So it will undoubtedly be a diagonal matrix, but the diagonal elements will be identical, means same. We can put something 2 in place of diagonal. Others must be 0, you know very well. So yes, this is the good example of a scalar matrix. What difference you obtain in scalar and diagonal? Children, the diagonal elements will be same in scalar matrix and all other non-diagonals will be 0 because every scalar matrix is a diagonal matrix. Are we clear? In this place you can put any of the particular number, it must have same value, whatever it is. That's why I have said K. Any constant, any number can be placed in the place of diagonal. That is called scalar matrix. Hope it's clear. The last type is identity matrix. The last type is identity matrix. Children, identity matrix is a scalar matrix, first thing. Identity matrix. These are represented by I, first of all. They are also the scalar matrices. Every identity matrices are scalar matrices and the diagonal elements are always 1 there. Identity means unit. So 1 0 0 0 1 0 0 0 1. See, this is the good example or specific, actually I should say, specific type of identity matrix is this. It is also known by the symbol I3. Why I3? Because its order is 3 by 3. And other is I2, means it will be of 2 by 2 order. 1 0 0 1. See. And I1 also we have. I1 will be equal to 1. Means this identity element is of order 1 by 1. All these are identity matrices, students. It will not have any variety in I3. I3 is fixed. Either you say it's an example or it's a standard form. I3 का ये standard form है, इसमें और कुछ नहीं मिलने वाला है, कुछ यहाँ और भी लिख सकते हैं. 1 is the only number to be left, to be kept in place of diagonal elements. Others are undoubtedly 0. Means by this way we want to say that every identity matrix is a scalar matrix. Scalar matrix is diagonal matrix and diagonal matrix is square matrix. So these are branches, means chain wise these all things have been discussed. These I3, I1 and I2, all these have the common name I. Identity matrices are usually represented by I for identity. Unit matrices also you can say them. Why I have written I3, I2, I1? Just to show their order actually. I3 means 3 by 3 order. I2 means 2 by 2 order identity matrix. I1 means 1 by 1 order identity matrix. Hope it's clear. The next topic we are going to discuss is equality of matrices, means how the two matrices are said to be equal. The concept is very easy. Children, once again I would like to remind that the matrices are the arrangement of numbers. So if you want to compare the arrangement of numbers, obviously they should be correspondingly equal. Let's see how it is, what I want to say. If the matrices A and B are equal, if the matrices A and B are equal, that is A equal to B, we want to say this implies Aij is equals to Bij, first condition, and second condition is order of matrix A must be equal to order of matrix B. What we want to say with these two concepts? By the first, we want to say that each corresponding elements should be equal, and the second concept says that their order must be same. Only then we can compare the two matrices. So these are the two necessary conditions. I think the example will help you to understand this. So let's have an example. Matrix A is equal to X 2 Y Z, and the matrix B is something, B is equal to 5 2 minus 4 6. If these matrices are equal, you can observe that all the corresponding places must be equal. Second place equal. X is equal to 5, Y equal to minus 4, Z equal to 6. This is the concept behind this. Means if the two matrices are equal, their each corresponding element must be equal. By this way we can say that X is equal to 5, Y is equal to minus 4, and Z is equal to 6. Children, I don't feel any problem will be there to understand. Two matrices are equal means all the corresponding elements are equal. That is why it is very necessary that their order must be same. Then only we can compare the corresponding elements. Otherwise, how it's possible to compare the elements? So these are the, and what this means, corresponding Aij, A11 equal to A11, A21 is equal to B21, whatever. Correspondingly, the elements should be equal. The last is, if the definition of the elements are given in any matrix, for any matrix, how can we construct a matrix? We will have questions in the first exercise, so I am telling you how to solve. The question should be like this. Construction of a matrix is the heading. Construct a 2 by 2 matrix, if the matrix A is equals to Aij, where Aij is defined as I minus j by 3. See the question, students. This question will help you to understand what is the meaning of construction of matrices. Construct a 2 by 2 matrix if a matrix A whose elements are Aij, actually this Aij is the symbolic name of each element of matrix A, where the definition of the element is given Aij equals to I minus j by 3. Children, let's have the symbolic form of solution I am doing, which will help you to understand. Let the matrix A is equal to A11, A12, A21, A22. Why this and how this? The question arises. A11 means the first row and first column element. A12 means the first row but second element, second column. First row but second column. A21, second row but first column. A22 means second row as well as second column. And why these many only? Because 2 by 2 it was. 2 rows and 2 columns should be there. It was indicated in the question itself. This is the whole question. Such type of questions are many more there in the book also, in the first exercise, which you will do today. So the question is again, construct a 2 by 2 matrix. If A equal to means the definition of, the elements are given in this way. This is the definition of the element. So now this definition will help you to know all these symbolic elements. A11, children, if Aij is this, how can you find A11? Tell me. A11 means I equal to 1 and j equal to 1 also. Please compare. Aij, A11 means one can understand. In place of I there is 1. In place of j also there is 1. So keep it right side also. 1 minus 1 by 3. It is 0 by 3 means 0. So we have obtained the first element. It should be 0 there. Similarly, let's go for A12. I is 1, j is 2. I1, j2. Putting again in the same formula. 1 minus 2 by 3. It is minus 1 by 3, children. So the second element is minus 1 by 3. Similarly, we will have A21, this place element. This one. A21. A21 means I equals to 2 and j equals to 1. Putting the values, 2 minus 1 by 3 means 1 by 3. And the last, A22. 2 minus 2 means 0 again. So putting all these in original form means their values. Putting their values, we will have the original matrix which had to be obtained. It is 0, 0 here and minus 1 by 3 and 1 by 3. Children, this is the answer of the question asked. Hope it is clear. And yes, this class will help you to go with the first exercise. I am sure you will be very comfortable to solve. Please start today onwards. Go with this, the whole video, once, twice, thrice, it depends on you, and then start exercise. Thank you very much.